Hi there, students. This is Unit 2, Segments, Lines, and Angles. Preview video 2.4, Segment Proofs. Take a moment, sit tall, ready, inhale. Hold your breath. Slowly exhale. You're taking a look right here at your preview notes. You're going to need your reference booklets as well today. So make sure you get your reference booklets handy. Don't forget the date, time, and location. Taking a look here, this is your review page. I'd like you to try this on your own. Pause the video. Welcome back. Hopefully you did this on your own. Let's do what we have here. We know that segment BC plus segment CD equals BD. There's your thing equation. Then you circle, plug, chug. BC, CD, BD. Solve for X. And you should have gotten X equals, and you go 23 to 17, that's going to be -6. You're like, wait a minute, negative? Really? Let's see if it works. So 17 minus 6 is going to be 11. 2 times -6 is going to make this -12, which makes this 3, and 3 plus 8, check, is 11. So negative was the correct answer. We're going to be talking about something called segment proofs. Now, you may have heard rumors about proofs. Do not be freaked out by that word. You actually do proofs all the time. Proofs are simply an explanation. We got an introduction doing this with algebra. Anytime you do any kind of research, legal work, okay, and even critical problem solving, you are doing, believe it or not, some variation of proofs, because it's just an explanation. Let's do something you're familiar with here. Let's do the math. And the reason for this step would be distance property on the left. Hi, guys. On the right. Now, we did not cross the equal sign, so this is addition and subtraction of real numbers. You guys know that as collect like terms. Coming over here, let's take this plus 15n over here. And this is going to be 14n plus 9 equals -5. And that would be addition and subtraction property, because we crossed the equal sign. Here we minus 9, of course, both sides, and we have 14n equals -14. That was addition, subtraction property again. And of course, our last step here, n equals -1, and that would be multiplication, division property. So this actually was a proof. We have the how here. What is the answer here? And then we have the why, the reasoning. Why is this mathematically legal on that side. That is what's called an algebraic proof. Today, we're going to transfer that same concept to geometry. Before you do that, you have to learn to be very observative. I'd like you to take a look from the top to the bottom and spot. Let's see how many differences you can spot on your own from top to bottom. Pause the video and restart. Okay, welcome back. I'm now going to show you where all the answers are. I'm going to take a look at that. When I grade your videos, hopefully you found at least 5. There's actually 9 if you're curious. So I like you to count the number that you got correct. How many did you correct? Put a little box there. See if you got all 9. If you didn't, try to figure out what did you overlook. Learning how to spot what changed is part of what we're doing today. Go to your reference booklet, please, and look for these pages. Unit 2. You're now in your reference booklet. I'll be checking this in your reference booklet next class. Just like we had algebraic properties, addition, subtraction property, multiplication property, distributive property, a cross multiplication property. You had all these algebraic properties. Today we're going to talk about 3 segment properties. One is a property that segments can be symmetric, and it looks like this. So if you had that segment, PQ is congruent to QP. Symmetric. Really hard stuff here. Now, reflexive is going to look a little weird, so I'm just going to write it down.
You have a technique today? No. Practice.
Reflexive means a segment that's shared by 2 distinct triangles. So if you look here, I have a triangle here on that side, and I have a triangle here on this side, and a segment that is shared by 2 entities. We write it like this. ST is congruent to ST. Wow. Here's another one. Here we have overlapping triangles. So you have a red overlapping triangle, AST, and an orange overlapping triangle, BTS. And those overlapping triangles, if you trace them, they exactly share ST. So we write again, ST is congruent to ST. That's called the reflexive property. Transitive, this is just very common sense. Transitive says this: if HI and IK are congruent, and IJ and JK are congruent, you can conclude that HI is congruent to JK. That's called transitive property. You transfer one. So if the first and second segment are congruent, second and the third are congruent, the first and the third are congruent. That's called transitive property. Next thing, we did this in class yesterday. Little segments add up to big segments. That's called segment addition. Segments can have midpoints, which means this would be true. AM is congruent to MB. So these are all different properties with segments. Now I'm going to walk you through a couple segment proofs. Now just bear with me. The big name of the game here is what has changed. When you do these kinds of proofs, I'm going to walk you through what's called the gift process. Given, implied, freebies, talk through. Given, implied, freebies, talk through. Given, implied, freebies, talk through. Gift. So step one, colors will be helpful here. I'm going to be using red, blue, green, and yellow if necessary. Colors come in very handy here. Ready? We're going to start with our given information. We are given that AD and CE are congruent, equal in length. Notice the hatch marks. We're also told in the same diagram that I'm using green, BD and DE are also of equal measure. We want to prove or explain if this big segments, the blue ones, are equal, and these little pieces are equal, how would we know for sure that these leftover segments are also equal? So you've been given here what is the answer. So the reason why proofs are a little strange is you're given the answer. You're like, well, if you give me the answer, what else is left? So what proofs address is how did you get the answer? So just write the word how here. And why is it mathematically logical? So I'm going to walk through. So given, you put the information on the diagram. Implied, what is implied? One thing that's implied here is that little segments add up to big segments. So we know this is true. It's implied. Given, implied. I know that AB plus BD equals AD. That's one thing that's implied. Little segments add up to big segments. I also know that ED plus DC equals EC. That's implied. Given, implied. Freebies. Freebies are things that are true, but not part of the given. This would be an example of a freebie. That's a true statement, but it's not part of the given. Talk through. Really important process. You talk through how do you know it's true. So in this case, we have here, if those big blue segments are equal and the little green ones are equal, how do you know the reds are equal? And that's because if you take away the green away from the blue, the red left over is the same. So you're not doing a blank proof yet. We're just going to work on the justification statements. So I'm going to color code this for you. So AD equals AB, which is the red, plus BD. And then we're down here, CE is the blue, CD is one of the reds, and DE is the green. So somehow we're trying to connect the two reds. That's where we're going. So we go here and we ask ourselves, why is this number one true? What's the property involved? And the property is simply segment addition. Little segments add up to big segments. So is number 2. Little segments add up to big segments. Now look at step 3 and ask yourself, where are you getting this information? AD is equal to CE. And you look, it's part of your given. Your given is your starter information. So why is that true? It is given. Now this is where it starts getting tricky. Look very carefully. Look at steps 1, 2, and 3. Ready? Look at what we did. AD, come up here, AD, physically touch what I'm touching, is equal to this. We swapped out AD and we put that in its place. Look carefully here. CE, CE. We swapped out CE and we put this, I'm going to circle it, in its place. We swapped this out and put this in its place. We swapped CE out and put that in its place. What is that property called? It's called substitution. And what lines did we use to substitute? We used lines 1, 2, and 3. Now look very carefully. BD and DE are equal. How do we know that's true? If you look, go back up here. How do we know that's true? It's part of the given. Now look super, super careful. Ask yourself this. What is the only difference between this line and this line? I actually want you to circle it. What is the only difference? It's like spot the difference here. What is the only difference? I'll give you 10 seconds. Look carefully. Look carefully. We swapped out BD and we put in DE. We swapped out BD and put in DE. There's a reason why. That's called substitution. And we substituted line 4 and line 5 to get line 6. Last step. Remember, we're trying to connect the reds, which are these two guys. Now look, you now have the exact same thing on both sides. Because you have the exact same thing, you can subtract the exact same thing from both sides. And if you do that, ta-da, you get what you're trying to prove, which are the red segments being equal to each other. Look carefully. Ready? Do you see how they're connected? You just logically prove that the segment AB and CD are of equal length. And the reason why, this last step, what changed? Subtraction property. Now I know this is way outside your comfort zone. Looks super weird. But let's try another one right here in your notes. Ready? Let's try another one. Given, implied, freebies talk through. We're going to color code it. I'm going to start with blue. CE and DF, in this case, are congruent and they're overlapping, so I'm going to overlap them. That's given. Let me keep my color straight here. So I have overlapping segments that are equal. We're going to try to prove or explain in this circumstance, how do I know that CD is the same length as EF? Okay, we have marked our given, implied and freebies. What's true? Well, here's something that's true. CD and DE equals CE. That's true. EF and ED equals DF. That's also true. That's called segment addition. That might come into play because what we're trying to prove is part of that segment addition for both. So let's come down below and see what happens here. Step 1. CE and DF are equal. How do I know that? It's given. This one, you are told that CE, ready? Let's come up here, trace it. CE equals to CD and DE. Let me color code that. DE is going to be right here. CD is one of the reds, which we're trying to connect, and CE is one of our blues. Okay. What is true here? What's true is the fact that that's called segment addition. Little segments add up to big segments. Now let's check this next one. Trace it. DF, trace with your fingers, DF equals DE plus EF. What's going on there? Little segments add up to big segments. That's called segment addition again. Let me color code that. That's blue. And that's the red and the green. Somehow we are trying to connect the two reds. Somehow we're trying to connect the two reds. So do you see in this step, if the two blues are equal, that means I can swap out CE and put this here, and I can swap out DF. Notice I'm boxing and circling, put that there. I could swap one thing out, put something else in its place, which I'm going to do right now. So I know if I take out CE, I can write CD plus DE equals, and then the box, DE plus EF. What is that called? That's called substitution. And what lines did I use? I used lines 1, 2, and 3. Always keep track of what you're trying to connect. I'm trying to connect CD and EF. Let's get real close. Notice DE's on both sides now, so I can subtract. You can only subtract when it's the same thing. So that's why we wanted to get the same thing on both sides. Minus DE. And when you do that, lo and behold, CD, EF. What is that called? Subtraction property, and we subtracted from line 5. I know this is looking weird. I promise you'll get better at it in class. Let's try one more together. That's it, just one more. Using the same 3 colors. Given, implied, freebies, talk through. Stay right with me. Mark your stuff on the diagram. I'm going to color code it again. AB and CD are equal in this case. This should be C up here. Hatch mark, I got that. BD and DE. Got that? Now, given the blue is equal and the green is equal, we're going to prove or explain how do we then know that A all the way to D and C all the way to E is equal in length. You talk it through. Real simple. If the two smaller pieces are equal and they add together to get the red piece, therefore the red is equal. Add, did you hear the word add? So let's see how that works here. So step one, I know that AD and CD are equal. Why do I know that? It's given. Okay, and you're like, uh-oh, now I got a blank on the left. What's up with that? So you kind of have to kind of see how things fit together. All right, so we're going to do, we know we need our second given, so that's most likely going to be our next step. You need to understand there can be more than one way to do proof, so I'm only showing you one method here. Okay, why do I know that's true? That's given. Okay, let's see what's here on the left. AD, physically trace it, which is this, always trace everything out, equals AB, trace it, plus BD, trace it. What's going on there? That is called segment addition. Okay, now this is where it gets a little weird. You're like, how do I know what to do next? Let's look here what step 5 is, and we're going to backtrack. Step 5 says that A to D is equaling to CD and DE. You're like, wait a minute, it's not a direct equivalent. What's going on there? So there's obviously something we need to say that's true before that. And what we need to say that's true before that is right here in the red is the fact that CE is equal to, if you go up here, CE is equal to CD plus DE. That's a true statement, and that's also segment addition. Now look very, 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 very carefully. Watch, it's important that you're circling. It's important that you're physically interacting here. Your brain will not get it through your eyeballs. It's going to get it through your fingertips. So circle with me and you'll understand that. Watch carefully. Circle. Okay, do you see CD and DE? Do you see that I could swap out AB and put in CD? And that's exactly what I did there. Do you see I could swap out BD and swap in DE? And that's exactly what I did there. Why would I want to do that? Why is that called? It's called substitution. And we substituted using lines 1, 2, and 3. Why would we want to do that? Look very carefully now. Do you see CD and DE? Shade it, CD and DE. Do you see box it? Do you see box it, box it, box it, box it? Do you see that's the exact same thing now? Now, because those black boxes are equivalent, we can now finally connect our two reds, which is AD is equal to CE. And the reason is substitution, and we substituted lines 4 and 5. There's your target. I know for a lot of you, this does not yet make sense. It will in class. I highly recommend in class you bring these 3 colors specifically so you can color with me. Make sure you have red, blue, green, and yellow. Those are the 4 colors that I'm going to be using when I do the next lecture. Take a moment and write a summary of the main concepts from today's lesson.